Welcome to the Deep Dive. Today we're cutting through the noise to get you the essential knowledge you need. We're looking at something really critical in aviation safety, the world of aircraft maintenance and overhaul, MRO, specifically. When crews have to go inside, well, probably the most dangerous confined spaces on an aircraft, the fuel tanks.
Yeah, that's a place most people, thankfully, never had to think about. But for the maintenance crews, it's incredibly high-stakes work. Our source material for this dive looks closely at RAMFAN Aircraft Ventilation Solutions. And honestly, it gives us a great window into the kind of engineering that's needed just to keep people safe in there.
Right. So our mission today is to really understand the science, the safety features, what makes this specialized ventilation tick in such a demanding environment. Because the core problem, as our sources really lay out, it's twofold for MRO crews, isn't it? You've got these lingering fuel vapors, which are, highly flammable.
Highly flammable, yes.
And then you've got the risk of oxygen deficiency in those tight, enclosed spaces. If that airflow system fails, well, people are at risk, compliance goes out the window, and everything just stops.
Exactly. And your standard industrial fan, forget about it. It's completely unsuitable. These specialized systems, they promise much higher protection. They're designed so crews can work faster, yes, but mainly safer, and stay fully compliant with aviation's incredibly strict safety rules. It really is life or death engineering we're talking about.
Okay, let's unpack that a bit. Why are these confined spaces like inside a wing fuel tank so much more dangerous than, say, other industrial confined spaces, maybe working in a ship's hold or a big vault? What makes the MRO environment so unique?
It really comes down to the volatility and the geometry of the space.
Yeah.
Aircraft fuel, especially jet fuel, is extremely volatile. And those spaces, the wing tanks, auxiliary fuel cells, they're designed to be sealed tight. They have complex internal structures, baffles. Our sources define those conditions perfectly. Confined, inherently flammable atmospheres, often leading to oxygen deficiency quite quickly. If that space isn't continuously actively ventilated, purge those flammable vapors, well, they can rapidly build up past what's called the lower explosive limit, or LEL.
LEL.
And once you're above the LEL, the entire workspace becomes a classified hazardous location, a HAZLOC. It's basically a potential bomb waiting for an ignition source.
Wow. Okay, so the engineering challenge is pretty intense then. You've got to clear out that toxic flammable air super quickly. But you also can't just pump it out anywhere, right? You have to manage where that contaminated air goes so it doesn't fill the hangar.
Precisely. Yeah, you can't just solve one problem by creating another one nearby. The solution needs equipment that handles really two main operational scenarios. The first is for the big jobs, the heavy maintenance and repair. That's where the RAMFAN Aircraft Fuel Tank Ventilation Kit comes in. Think of it as a complete heavy-duty system. It's built rugged, designed for sustained use during deep fuel tank work, cleaning, sealing, structural repairs. It handles those complex, long-duration ventilation needs, keeping the air safe and compliant for hours on end.
Okay, that covers the big overhaul jobs. But what about quicker tasks? Not every maintenance check needs hours inside the tank, surely.
That's right. And that's where the second product our sources highlight comes into play, the RAMFAN Wing Tank Vent Cart, the EB7325-WT model. This one is described as highly portable. It's basically a self-contained unit on wheels. It's really designed for rapid deployment. Quick setup for jobs like pre-flight ventilation checks or maybe shorter routine fuel tank servicing. The goal there is minimizing the aircraft's downtime while still maximizing safety. Get it in, do the job, get it out safely.
Okay, this is where it gets really interesting for me. You're forcing huge amounts of air that's potentially explosive past an electric motor. Doesn't the fan unit itself become like the single biggest ignition risk? It seems almost paradoxical. The safety solution could be the danger.
That is the fundamental conflict, yes. And it's what this specialized ventilation has to solve. You simply cannot use any equipment that isn't meticulously engineered and certified as explosion-proof. It's non-negotiable. The motors, the wiring, the switches, all the electrical components have to be designed either to contain any potential spark internally or, better yet, eliminate the possibility of a spark altogether. This isn't just, a nice-to-have safety feature. It's the core purpose of the entire system. Without that explosion-proof design, you're actively creating a catastrophic risk.
I definitely see the necessity there. But let me push back slightly. Let's say an MRO facility primarily works on, domestic flights within North America, a controlled hangar environment. Why would they need to invest in equipment that's certified for use in, say, Brazil or Europe or the Middle East? Why pay what I assume is a premium for global compliance markings?
That's actually a really great question, and it gets right to the heart of how the global aviation industry works, the whole supply chain.
Yeah.
Think about it. The aircraft themselves, fly globally. They are international assets. So when our sources list those specific international compliance markings, things like ISEX, in Metro, and the CE hazardous location markings, what they're doing is guaranteeing that this equipment is suitable and recognized as safe pretty much anywhere in the world.
Can you break those down just a little? Like IE6, what does seeing that label actually mean for the technician using it or the manager buying it?
Sure. So IESEX, that stands for the International Electrotechnical Commission System, for certification to standards relating to equipment for use in explosive atmospheres. Bit of a mouthful. Yeah, just a bit.
But what it means practically is proof. Proof that this specific piece of equipment has been independently tested and verified not to cause an explosion when it's used in those highly volatile gas zones we talked about. And that proof is accepted internationally, whether your hangar is in Dubai, Singapore, or Munich. Initro serves a very similar purpose, but it's specifically recognized and often required for Brazil and parts of the large South American aviation market. CE marking covers European requirements.
Okay. So that global certification isn't just about the manufacturer wanting to sell everywhere. It's actually essential for the MRO facilities themselves, because they could be working on a plane that just flew in from anywhere,
Tough.
carrying different fuel types sometimes, operating under potentially different local rules. They need that highest common denominator of safety assurance.
Exactly right. It simplifies everything. It streamlines regulatory compliance for the facility. It ensures the equipment is universally operable no matter where the plane came from or where it's going next. And it just removes any doubt about safety standards across different jurisdictions. Okay, so we've established the absolute non-negotiable safety side, the explosion proofing, the global certs. Let's talk efficiency. Because in aviation, time on the ground is money lost. What other performance factors, beyond just being safe, are critical for speeding up that maintenance turnaround?
Well, first and foremost, you need raw power, sheer high airflow performance. It's not enough just to slowly circulate air or maintain a barely breathable level. You need to purge that space rapidly. That means strong, consistent airflow to physically push the fuel vapor concentration down below that critical LEL threshold and do it quickly. That allows workers to get inside sooner, safely. There's a direct link between how powerful the fan is, how quickly the air quality improves, and how many hours you can shave off the maintenance cycle.
And these units, they're probably getting dragged around hangars, maybe used outside on the tarmac sometimes. What about durability? We talked about the fan motor being a potential ignition risk if things go wrong. How does the physical toughness of the unit tie back into that explosion safety aspect?
That's a crucial connection. This is where something like the ingress protection rating and the IP55 rating mentioned in the sources becomes really important, and is deeply tied to the safety mechanism.
Mm.
So IP55 tells you the enclosure is robust. It protects the internal components from dust ingress, that's the first 5 foot, and from low-pressure water jets, like rain or cleaning spray, that's the second 5 foot. Now imagine a fan that isn't properly rated. It's sitting out on the ramp, maybe it gets wet, or it sucks in some fine metallic dust from grinding operations nearby.
Uh-huh.
That moisture or dust could potentially cause a short circuit in the motor or cause it to overheat. And that short circuit, that overheating, that potential spark, that's exactly what the explosion-proof design is meant to prevent in the first place. So you can think of the durability rating, the IP rating, as a fundamental secondary safety feature. It prevents external factors from compromising the primary explosion-proof protection.
That makes perfect sense. The durability stops things from getting in that could bypass the safety design. Okay. And finally, aviation MRO deals with such a huge variety of aircraft, right? You might be working on a small regional jet one day and a massive military cargo plane the next. The ventilation setup has to be flexible, I imagine.
Oh, absolutely. That operational agility is key. It comes from what the sources call adaptable configurations. They mention things like modular designs, different kinds of flexible ducting and hose connections. This allows the technicians to basically customize the setup. They can configure the system to create an effective seal against specific wing shapes, different access port locations, or fuselage panels, whatever the aircraft model requires. That adaptability is really crucial for MROs that handle diverse fleets. It means they can use the same core equipment efficiently across many different jobs.
So if we boil it down, the overall engineering philosophy here seems to be this really complex blend. You've got industrial grade, certified explosion protection meeting, well, practical, field-tested usability, all designed to maximize both worker safety and the speed of maintenance.
Precisely. You said it perfectly. These systems are the essential bridge between strict safety compliance and the demanding operational tempo of the aviation industry.
Okay, let's bring this right back down to the hangar floor. For someone listening who manages MRO schedules or oversees safety, What are the absolute main can't-avoid-them applications where these specialized ventilation systems are deployed?
Well, our sources point to three main areas, really. First, obviously, fuel tank maintenance and inspection. This covers everything from routine checks to fixing fuel leaks, replacing seals, doing internal structural inspections or repairs. Using controlled, certified ventilation here minimizes the crew's exposure to those hazardous vapors during potentially long tasks involving cleaning solvents and fuel residue.
Makes sense. And the second area would be just getting people into the space safely to begin with.
Yes, exactly. Confined space entry operations. This is where the fan isn't just cleaning the air, it's actively preventing oxygen deficiency. In those really tight spots, like wing tanks, integral fuel cells,
Hmm?
the continuous airflow is quite literally life support for the technicians inside. And then thirdly, they play a vital role right at the end of the process, purging confined areas of any residual contaminants before the aircraft is certified, signed off, and returned to service. That final purge ensures air quality standards are met, critical for quality control and those rapid turnaround operations.
So if we zoom out again to the bigger picture,
Hmm.
beyond protecting the individual worker in the tank, why is this sophisticated, highly certified ventilation so essential for the aviation industry as a whole? What larger risk does it help manage?
I'd say it's about mitigating risk at the highest level. These systems are crucial tools for MRO teams to meet those extremely stringent aviation safety regulations, but also environmental ones. A key part is controlling the release of flammable or toxic vapors. If those vapors were allowed to just vent freely into a busy hangar,
Oh, wow, yeah.
you could endanger the entire facility, potentially ignite adjacent aircraft being worked on, risk the safety of everyone present. It's really about containing that specific hazard right at the source, inside the tank.
And given that the source material mentions its use across the board, general aviation, commercial airlines, military maintenance depots, it seems that this need for explosion-proof, high-performance ventilation is truly universal wherever serious aircraft maintenance happens.
Absolutely. The fundamental physics and risks don't change whether it's a small plane or a giant airliner. The need for verified, purpose-built equipment that meets those strict HAZLOC standards, it spans every single sector of flight maintenance.
This has been a really insightful look into something most passengers, myself included, probably never even consider. But it's absolutely critical infrastructure for the safe operation of literally every flight. I think the core takeaway here is that reliable aircraft maintenance safety, especially in fuel systems, it just isn't possible without certified, explosion-proof, and adaptable ventilation. It's this constant balancing act, protecting the technicians while also enabling the efficient, compliant, fast turnarounds the industry absolutely depends on.
That's a great summary. And it leads to maybe a final thought for you to mull over. We've talked about how these systems need global certifications like ISEX in UN Metro, and how they rely on adaptable, modular designs, those flexible hoses and connections to fit all sorts of different aircraft worldwide. So given that adaptability, what unique logistical and perhaps training challenges do large international MRO organizations face? How do they ensure that every technician in every facility in every country is not only using these adaptable configurations correctly for each specific aircraft, but also maintaining the ventilation equipment itself properly? That very flexibility, which is such a huge operational asset, must also introduce a layer of complexity when it comes to standardizing procedures and ensuring the tools themselves are always used safely and effectively across a global network. Something to think about.